Hello friends, today we are going to see the topic optical link design. In this we are going to see basically 3 points. What is design criteria for optical link design? What is the approach of power budget calculations and what is the approach for rise time budget calculation? So basically first we will understand what is the concept of optical link. So the word optical link stands for whenever we are connecting optical transmitter and optical receiver with the help of fiber optic cable, that is called as optical link. So simply speaking, optical link is nothing but it is the optical communication system in which transmitter and receiver are connected with the help of fiber optic cable, that is called as the optical link. So there are different parameters which we have to consider in optical link design, but few of that we are going to consider here. So as we discuss the optical link meaning, then the next question is why to design the optical link. So the optical link design, it is essentially putting the various components or optical components whatever we have discussed earlier. So up till now we have, so this is going to be the last chapter in the syllabus. So up till now whatever we have seen, all the components, that optical source, two types of optical sources we have studied, LED laser, optical detectors we have studied as PN photodiode, PIN photodiode, avalanche photodiode. We have seen the different types of fibers like step index fiber, graded index fiber. So whatever are the concepts that we have studied, how to apply that knowledge of the concept to design the optical practical communication system, that we are going to consider in this chapter. So the optical link design, it is essentially putting the various optical components whatever we have discussed earlier so that the information can be transmitted satisfactorily. The satisfactoriness of the transmission can be defined in terms of some characteristics or parameters. So whenever whatever information we have transmitted, when it is received by the receiver, then only the system or communication system it is efficient. That is the basic concept, but still to define the performance of the system there are some specific parameters that also we are going to consider. Then the designer has to generally define some additional criteria as per the standards or as per the specifications. So the primary design criteria for link design, it is data rate and link length. So in this, the primary design criteria first we will understand, then we will go for the secondary or additional criteria. First we have to understand data rate. Data rate means the rate at which we are transmitting the bits through the particular communication system. So primary design criteria, it is data rate. Whatever is the required data rate, that must be achieved to consider the performance of the system. Then link length. Link length basically stands for what is the maximum allowed length of optical fiber for the particular communication system. Suppose there are two systems. One system can operate up to 1 kilometer distance. Another system, it is able to operate up to 10 kilometer. So whatever is length of optical fiber we are going to use in that particular systems, that length is obviously not same for the both the systems, it is going to be different. So that is nothing but the link length. So these two criteria are the primary design criteria that we have to consider. Then along with this, some additional design parameters we have to consider. So first parameter we have to consider modulation format. So modulation of light we are going to do whenever we are transmitting light through fiber optic cable, we are doing nothing but modulation of the light. So modulation format, for example, if it is analog or if it is digital. So depending on which signal we are going to transmit, whether analog signal or digital signal, that modulation format it is selected. So when we say analog modulation, in that, so for any type of modulation of light it is acting as a carrier. and whatever signal we are using to modulate the light, that signal it is acting as a modulating signal. So depending on the type of the signal which we are going to transmit, the modulation format it is decided, and whether we are going to select analog modulation or digital modulation. So depending on the type of signal, for example, if we are going to transmit the TV signal, then in that case we are using the analog transmission that requires the less bandwidth and it is providing the better linearity. If we are going to transmit data or some sampled voice, in that case we have to choose the digital format, means we have to go for the digital modulation. The digital signals have to be further coded to suit the transmission medium and also error correction. So if we are using the analog modulation method, the basic three modulation methods of analog modulation as we have studied already in analog communication: amplitude modulation, amplitude modulation, frequency modulation and phase modulation. These three formats are used. And if you are considering the digital signal, in that case we have to use the encoder at the transmitter side and decoder at the receiver side. Based on our information, we are going to choose the modulation method. Then another parameter we have to consider: system fidelity. System fidelity, basically the word fidelity, in case of communication, the word fidelity stands for whatever frequency components are transmitted by the transmitter, all that frequency components should be able to be recovered at the receiver. If all the frequency components are recovered at the receiver, then we are saying that fidelity of the system it is good. So system fidelity consists of bit error rate and signal to noise ratio. If we are considering the analog modulation method, in that case the signal to noise ratio it is considered as performance parameter. If we are considering the digital modulation system, in that case we are using the bit error rate as the performance parameter. So same concept it is explained here. System fidelity defines the correctness of the data received at the receiver. So as we discussed, whatever components have been transmitted, all that should be received at the receiver. That is the concept of fidelity. For digital transmission, it is measured in terms of bit error rate, which is defined as it is ratio of number of bits in error divided by total number of bits transmitted. So this is the frequently asked question in the MCQ. Which parameter it is considered main performance parameters in the link design? So that is nothing but bit error rate. It is in case of the digital communication system. And for analog and for the bit error rate, it should be less than 10 raised to minus 9. If we are considering the analog system, then in that case signal to noise ratio it is the performance parameter, or it is the parameter from which the fidelity it is defined. So it is, all of us know that SNR ratio stands for it is ratio of signal power to the noise power. Also there is a parameter called as the intermodulation distortion, which describes the linearity of the system. Then these two are the basic parameters: modulation method, system fidelity. Then next performance parameter for design it is cost. So we have to by default consider cost of the optical communication system. For example, for your project or for your small project, whatever you are going to present, let us consider for some small project competition. So in that case, though laser is giving a very better performance as an optical source, but as the device it is costly, we cannot afford it. So cost is the major parameter that we have to consider for any optical communication system design. Then same points are explained here. The cost consists of component cost, installation cost of that communication system and maintenance of the system. All these costs we have to consider whenever we are going to consider cost for the link design. Cost is one of the important issues for the link design. The cost has three components: component cost, installation cost and maintenance cost. initially we have to consider whatever is the components used in that link design, what is cost of that components, what is the cost for installation of that system, and what is the cost for maintenance of the system. By considering all these values, the total cost of the design of the system it is calculated. The component and its installation cost are the initial cost, and generally the installation cost it is much higher than the component cost for the long links. So for example, one system may require less amount for its design, but for the installation of that particular system the more cost may be required. This is especially true for laying in the optical cable, and once the system it is installed, after that its maintenance it is the further cost that we have to consider. So it is expected that once the optical link it is established, it should work at least for 25 years. The maintenance costs are as important as the initial cost. An initial cheaper system might end with higher expenses in the maintenance. So it is quite obvious. If initially you are considering about the cost, and if you invest less amount for that particular system design, and if it doesn't work properly, obviously you have to invest more amount for its maintenance. Then the another parameter for design consideration it is upgradability. So the optical fiber technology, as we know, it is changing very rapidly, and different inventions are made in the optical fibers. So the criteria upgradability stands for the system should be able to adopt new technology, as well it should be able to accommodate higher data rates with least possible changes. So for example, if today I am designing one system that is able to operate at 100 bits per second. So for example, let us consider if today I am designing some system which is operating at 100 bits per second, but for the next application I want the bit rate should be very high. So if I want it as 1 lakh bits per second, so that changes should be adopted or upgraded in the system without the maximum changes. So all these parameters we have to consider as a additional design parameters for optical link design. And last parameter it is commercial availability. Depending on which part of the world one is, the availability of the components and the system may be an issue. So whatever system we are going to use, whatever components we are going to use for design of optical link or design of optical communication system, that should be available, or commercially the component should be available. It should not be the case that whatever component we are using that is very rarely available, or if some error it is happening in the system and if we want to replace the components, availability of the component should not be the issue. So all these design parameters we have to consider in the optical link design. So right now we are considering the first part of this particular video, that is link design. In that first we have seen what is the parameters that we have to consider for optical link design. Now there is one approach which is commonly used for optical link design, and that approach it is called as point to point optical link. So point to point optical link, it is nothing but we are connecting the transmitter, after that we are connecting optical fiber cable, and after that we are connecting the receiver. So whatever is our regular connection, that is called as the simple point to point link. So the diagram it is shown. So what are the blocks in the point to point link? It is first one is information source. So obviously the information source it is generating the electrical signal. It can be analog or it can be digital based on our application. So first one it is information source. Output of that information source it is given to the optical transmitter. So optical transmitter consists of modulator. For example, if you are transmitting analog signal, obviously the modulating part it is optional number of times. Optical transmitter consists of modulator and optical source. So the essential part in optical transmitter is nothing but optical source, which will convert the electrical signal in the form of light. When the electrical signal is converted in the form of light with the help of this optical transmitter, then the light signal it is passed through fiber optic cable. So fiber optic cable is carrying the light signal, it is given to the optical receiver. So always first block in the optical receiver, it is going to be the optical detector. The optical detector will convert the light signal in the form of electrical signal. Then if we have used modulator, the block we have to use in the receiver as demodulator. So if we are transmitting digital signal, we have to use encoder in optical transmitter, and we have to use decoder in the optical receiver, and then the received signal it is given to the user. So the link, it mainly nothing but it consists of optical transmitter, optical fiber, and optical receiver. Then the link design can be divided into three parts: design of optical transmitter, selection of optical fiber, and third one it is the design of optical receiver. So whenever we are going to design optical transmitter, we have to consider basic parameters. That first, as we discussed, based on which signal we are going to transmit, we have to select the proper type of modulator to increase strength of that particular signal. Then next, depending on our requirement, we have to select the proper optical source. So as we discussed, there are two types of optical sources, chromatic and non-chromatic. So based on our requirement, we have to select the chromatic optical source or non-chromatic optical source. If you are selecting LED, again you have to consider your parameters and you have to select the proper type of LED. Similarly, for laser also we have to consider that which type of laser we have to select, that is related to the optical transmitter. Then output of optical transmitter it is given to the optical fiber. So while selecting the optical fiber, we have to consider our requirement and proper type of optical fibers should be selected. For example, if we are using the multi-channel application, we cannot go with the single mode optical fiber. Compulsory we have to use the multi-mode fiber in such cases. So there are different types of fibers we have studied: single mode fiber, multi-mode fiber, step index fiber, graded index fiber. So based on our requirement, we have to select the proper type of optical fiber. Then the next concept is design of optical receiver. So as we have considered the parameters for transmitter design, similarly we have to consider the parameters for optical receiver design. So in receiver design, we have to consider the first block important, that is selection of optical detector. So the very first block in optical receiver, it is going to be detector. So based on which type of optical source you have used, matching with that we have to select the optical detector. So there are basically two important devices which are used as optical detector: photodiode and phototransistor. In photodiode you can select PN photodiode, PN photodiode, or avalanche photodiode based on our requirement. So first task it is selection of proper optical detector. Then next, the optical detector, after that we have to use the demodulator. If you have used modulator in the transmitter, we have to use here the demodulator. If encoder it is used in transmitter side, we have to use the decoder in the optical receiver, and then the signal it is given to the user. Again, in case of optical receiver, there are two types of receivers: analog receiver and digital receiver. If we are using the analog signal, directly it is given to the demodulator block. But if we are using the digital signal, we have to use some decision making circuit, because whenever the digital signal is transmitted through fiber optic cable, due to the different losses in the optical fiber cable, the shape of the digital signal it is not maintained in the exact digital form. So to again convert it into exact digital form, we have to make some decision making circuit, which is frequently referred as the comparator. So these are the points related to optical receiver. So these three parameters we have to consider in case of optical communication system design, or it is also called as point to point optical link design. So the next figure it is there, whatever is showing the typical optical power which LEDs and the lasers can deliver and the photo detector needs for a bit error rate of 10 raised to minus 9. So as we discussed that bit error rate is important performance parameter in the optical link design. For that particular bit error rate of 10 raised to minus 9, what should be the values of LED powers, laser powers and photo detector powers, that is given in the diagram. So we will see that diagram. So there are different types of LEDs, it is mentioned here. SLD, that stands for superluminescent LED. that stands for multimode fiber. LED, then graded index fiber. LD, multimode fiber, graded index fiber. So by considering the cost of the system and by considering the overall performance parameters of the system, we can select the particular range, or we can select the particular device and their ranges for a specific application. So by considering the cost, speed, etc., first choose the laser and the detector. Also the type of fiber it is chosen from the above table. Generally a multi-core fiber is laid even if the immediate requirement is only one or two fibers. So single mode fiber, though it is giving the minimum dispersion, the whatever is amount of light that can transmit through single mode fiber, it is very less. So based on our requirement, the chart it is just given for a reference. So by it is not the case that we have to consider only the transmitter side. Even though, as I told, even though laser is giving very high good performance and it is used for small scale application, we cannot afford the laser as optical source. In that case, obviously we have to select the LED as optical source. So by considering all these parameters, we have to select the optical devices. Then the link design then reduces to finding locations of the repeater after a long link. So repeaters are also used in case of optical link design, which is used to increase the strength of the signal for long distance transmission. So that is the first point related to optical link design. Then there are two calculations are carried out in the link design, means to design. So first we have seen the concept of link, what parameters are to be considered in the link design, what are the performance parameters that we have to consider before the optical link design. So that is the introductory part. Next we are going to see there are two approaches for optical link design. First approach, that is called as link power budget. So first approach we are considering as link power budget, and second approach we are going to consider as system rise time budget. So try to understand what these two approaches are telling. So initially we have seen the introductory part about the link design. Now we are going to see actually which type of approaches are used for practically link design of optical communication system. So suppose you have designed or you have selected proper transmitter, proper receiver, then which approach you have to use for link design. So there are two approaches. First one, it is the system power approach, and another it is the system rise time budget. So in system power approach, the main focus it is given on power requirement of the system. So as we are knowing that whatever is power transmitted by transmitter, same we are not able to get at the receiver. So in the diagram it is shown optical transmitter that is emitting some optical power, and receiver it is receiving the optical power, and obviously the power transmission it is taking place through the optical fiber. So let us see the diagram one by one. So the first block, it is optical source that will generate the optical power, then through optical transmitter it is transmitted. So in between the transmitter and receiver, we have used the splices and the optical joints and optical connectors, optical fibers. So splices are nothing but the permanent joints between the two optical fibers, and connectors are the temporary joints between the two optical fibers. So all these components are having some power loss. So suppose X is the power transmitted by transmitter and Y is power received at the receiver. So value of Y, it is obviously less than X, and what are the parameters because of this the power it is reduced, that are shown in the diagram. So the power loss takes place because of splices, power loss takes place because of connectors, the power loss takes place because of the different loss mechanisms that we have seen in case of optical fibers. So because of this the losses are taking place. The fiber loss depends on the wavelength and also the physical conditions of the optical fiber. The fiber loss is generally higher than that the specified by the manufacturer. This is primarily due to micro bending of the optical fiber. So already we have seen the different types of losses. Those are taking place in the optical fiber. So because of that, whatever power it is received at the receiver, that is not same as that of power transmitted in the transmitter. So this is the approach we are going to consider in the link power budget. So power budget calculations. So and again the values of the different losses because of splices, connectors, that values are given here. Splices are giving the losses of 0.05 to zero point 0.1 decibel per splices, and connectors are giving the loss in the range of 0.2 decibel to 0.3 decibel per connector. So now we will see actual what is the calculations for power budget approach. So suppose PS is the power transmitted in the transmitter side. So in this we have to calculate. So in link power budget, by considering the transmitter power and received power at the receiver, we are going to calculate the maximum allowed length of the optical fiber. That calculations are there in the power budget. So let us say that PS is power transmitted in the transmitter and PR is sensitivity of the receiver in dBm for given bit error rate. So or we can say that PR, it is the minimum power required at the receiver. So if PS is the transmitted power and PR is minimum power required at the receiver, the maximum permissible losses, so up to what the losses can be tolerated, that losses are given by PS minus PR. Then maximum losses consist of, so what are the, so alpha max, that is the maximum permissible loss. So alpha max value, that is because of, in that we have to consider losses in between because of fiber, losses because of connectors, losses because of splices, and losses because of the particular system. So whatever is the alpha max, that is given as alpha fiber plus alpha connector plus alpha splices per alpha plus alpha system. So alpha fiber can be written as alpha max minus all these values of addition of alpha connectors, alpha splices, and alpha system. And from considering the values of alpha max and losses in the fiber, the maximum allowed length of optical fiber, it is given as, or that is also called as maximum allowed link length, that is given as LP max is equal to alpha fiber divided by loss per kilometer. So in this we are going to calculate the maximum allowed length of optical link by considering the 2 points as maximum allowed loss and losses in the optical fiber. So beyond this distance, the SNR is below the acceptable limit. So for example, by using this calculation, if we are getting the maximum allowed length of optical link as 2 kilometers, means up to 2 kilometers only we are getting the expected SNR ratio. If length of the link, optical link, it is more than this 2 kilometers, we are not getting the SNR as per our requirement. So in that case the SNR, it is below the acceptable limit. That is the first approach, power budget calculation, in which the major parameter it is considered as transmitted power and receiver power. System margin is generally taken to be 6 dB to accommodate deterioration of components over time. So in the diagram, based on the distance, the power levels are decided, that what should be the power of LED, what should be the power of laser. So based on the distance, the power levels are decided for the particular components. This is the first approach. Now the second approach which is used for link design, it is system rise time budget calculation. So in link power budget, the more focus it is given on power transmitted at transmitter and power received at the receiver. Whereas in rise time budget calculation, we are going to consider the delay present in each component in the optical communication system. So rise time analysis gives effective bandwidth of the particular link. So overall system delay, that is calculated as T, so that is given by the symbol as TSYS, that stands for maximum delay of the system or overall delay of the system, that is calculated by taking square root of square root of addition of square of all the components whatever are used. So TTX stands for delay produced in the transmitter, TRX stands for delay produced in the receiver, D square, gamma square, L square, these are the components which are present in the optical fiber. For example, D stands for the dispersion, L stands for length of the optical fiber. So whatever is the middle term, that is given overall delays produced in the optical fibers. So by considering delay in the transmitter, delay in the receiver and delay in the optical fiber, the overall delay of the system it is calculated. So that is the concept of system rise time budget. So in that also, by considering this formula, the T system should be less than or equal to 0.7 of TB, that is the whatever is the bit error rate we are considering. So T system should be less than 0.7 of TB. So rise time limited link design. So link length equation whatever we got in case of power budget approach, that was in terms of alpha max and loss in dB per kilometer, and here the rise time limited link length, that is given by LRT max is equal to 1 divided by D gamma lambda 0.7 TB square minus TTX square plus TRX square whole bracket raised to 1/2. So by using this formula we can calculate what is the allowed maximum length in case of system rise time budget calculation. Beyond this distance, if length of the link it is selected, again we are not able to get the required expected SNR ratio. So both the approaches are deciding what is the allowed length of optical link. In power budget, the link length is calculated by using the power values, and in rise time budget it is calculated by using the delays present in transmitter, receiver and delay present in the optical fiber. So beyond this distance, if link length goes, in both the cases we will not get the required SNR ratio. Rise time of a system or component, that is inversely proportional with the bandwidth. If rise time the word stands for here delay in the system. If rise time is more, bandwidth of the system it is less. So that is given in the next sentence. So these are the two approaches considered for optical link design. So TSYS stands for total system rise time, TTX stands for transmitter, TRX stands for reverse rise time, D stands for dispersion in the fiber, gamma lambda stands for spectral width of the transmitter, L is length of the fiber, and TB is the data bit duration, that is given by 1 by data rate. So in the link design, two lengths, the power budget length is LP max and rise time budget LRT max are calculated. The repeater has to be installed at distance whatever is minimum between LP max and LRT max. So these are the two approaches used for the link design. Then in such a way we have seen that three parameters related to optical link design. First, what is the concept of optical link, why we need to use the optical link, what is the design criteria for optical link design, how to calculate the link or how to consider the link design by using power budget approach, how to consider the link design by using the system rise time approach. So these 3 points we have considered. Apart from this also, based on the application, there are certain changes in the requirement of the components, and we have to select the components such that it can be easily replaced and it can be easily available in the market. Okay, thank you.